Chemical safety training. Let's see what you will learn in this video. Required training. Overarching principles. Standard, required, practices. Alarms and evacuation. Safety equipment, eye washes and showers. First aid health center. Fire safety. Personal protective equip. Fume hoods. Safety data sheets and related. Chemical handling and storage. Chemical spills. Floods and flood prevention. Electrical hazards. Personal safety crime. Links and resources. Cryogens. Perhaps our most common injury accident. Assessment and brief homework. Required training. If you will work with chemicals, hazardous materials. A. Attend EHS safety workshop that includes chemical safety, or Number 1. Core Injury and Illness Prevention Plan, IIPP. Number 2. Core Emergency Preparedness Training. Number 3. Chemical Safety Training, 4 individual units. Number 4. Fire Extinguisher Training. Number 5. Personal Protective Equipment, PPE. If you will have zero contact with chemicals or hazardous materials. A or B, number 1, number 2, number 4. Overarching principles, a warm-up. Always follow standard practices for clothing and protective equipment. What are these? Before you do anything, evaluate potential hazards and then plan your actions. What are some possible hazards with your research? How can you find the hazards associated with chemicals? Are any special hazards, electrical, laser, biosafety, present? Are any engineering controls needed? What might these be? What types of personal protective equipment are needed? Be prepared for an emergency. Where is the nearest exit, eye wash, fire extinguisher, shower? What should I do in the event of a fire, flood, chemical spill? Required practices, clothing, behavior, and personal protective equipment. Clothing. No open-toed shoes, sandals. If your research involves machinery with moving parts, belt drives, avoid loose clothing and neckties or necklaces. Eye protection, goggles or safety glasses required unless specifically exempted. Ask if you are not sure. Approved lab coats required, except where specifically exempted. Ask if you are not sure. Working alone is not allowed for inexperienced investigators and not encouraged for anyone. Food drink, not allowed in any areas in which chemicals or biochemicals are stored, used or dispensed. Gloves are discussed later. Summoning emergency. Responders, fire alarm. Fire, unless very minor. Major chemical spill or toxic leak. Only easy way to evacuate building. Pull down alarm. Leave building. Fire alarm, what should you do? Exit immediately via stairs. A fire can quickly trap you. Close office and lab doors behind you. Do not re-enter the building until the all clear signal is given. Tornado alarm. Stay away from windows. A tornado is likely to shatter windows and create flying glass shards. Do not go outside. Even if the alarm does not sound, seek shelter if you hear the city alarm or if authorities broadcast a tornado warning. Power outages. If a power outage lasts more than a few minutes, turn off equipment that might be damaged or cause damage when power is restored. Leave the building by the stairs. First aid procedures. Major bleeding. Put on gloves and safety glasses. Apply pressure. Yell for help so someone else can summon ambulance. Chemical splashes. Arm or hand or face, wash in a sink with lots of water. In eyes, wear goggles, Use eye wash with lots of water. Remove any contaminated clothing. Get under a safety shower. Once you have removed the chemical, seek medical treatment. Personal protective equipment required for work with chemicals. Splash goggles or safety glasses. Use goggles or a face mask when working with splash hazards, particularly corrosive agents or toxic materials. Asterisk additional protection may be required for work with lasers or high-intensity UV. Check with your advisor and EHS, SOPs. Lab coats. Supplied by department. Swap out dirty coats for laundering. Shoes with continuous tops, no sandals or open toes. Recommended, long pants. Gloves. Disposable nitrile gloves are usually okay for transient protection. Immediately replace damaged or contaminated gloves. Grasp the sleeve and pull it towards your fingertips, inside out. Wash your hands before regloving. Fires, should you fight or leave? You can fight a fire if the fire is confined to a small area. You are not alone and you are in no danger. You need another person as backup and to call for additional help if needed. You have a clear exit path. Do not attempt to fight a fire that is large or uncontained. Poses a danger of trapping you. Poses a danger of smoke inhalation. Poses a danger of exposure to hazardous materials. Dry chemical extinguishers and when to use. Carbon dioxide, excellent for fires near computer electrical equipment, small solvent fires. Dry powder will quickly knock down most solvent and chemical fires and those where CO2 would react with the burning material, example, sodium. Never use on people. After using a dry powder extinguisher, turn off computers and electrical equipment to minimize damage. Fume hoods. Toxic, flammable, or corrosive materials must be handled in a fume hood. Do not allow gloves, paper towels, plastic, or foil to be sucked into the back of the hood. Minimize use for storage. Place bulky equipment towards the rear of the hood and allow greater than or equal to 2 beneath for airflow. Work as far inside the hood as possible and try to minimize the amount the sash is open. Chemicals. What is a hazardous material? A hazardous material is anything that is flammable, corrosive, reactive, an oxidizer, toxic, carcinogenic, etc., or breaks down to give species with any of the above categories. Examples: acetone, flammability, 1-HCl, corrosive, sodium cyanide, toxicity, chloroform, cancer suspect agent. Chemical transport. Transport of any hazardous materials outside of your lab requires secondary containment, which can be either a specialized container or a sturdy plastic pail. Containers must be securely closed. Chemical storage. Flammable solvents. Large quantities in safety containers or in safety cabinets. Segregate by hazard. Oxidizers, separate from flammables, reducing agents. Water reactive, protect from water, segregate from flammables and oxidizers. Inorganic acids, segregate from organic acids, flammables. Toxic materials, includes carcinogens. Segregate, protect from cross reactions. Segregation can be based upon secondary containers, for example, plastic tubs. Peroxide-forming molecules. Shock-sensitive and explosive peroxides may form on prolonged exposure to oxygen or air and detonate upon concentration, heating or friction. Diethyl, ether, tetrahydrofuran, THF, 1,4-dioxane, and cumene are notorious, but you can have problems with old containers of secondary alcohols, example, isopropanol. Peroxide formers should be used or disposed of within 90 days of container opening, date upon opening, or you can also test for peroxides with commercial strips. Chemicals, gas cylinders. If the regulator is snapped off, the cylinder can become a rocket. A protective cap is required for storage or transport. Gas cylinders need to be secured in the lab with a strap. When being transported, they need to be secured to the cart with a chain. Chemical labeling. Chemicals must be labeled to permit unambiguous identification. Labeling of materials for disposal has much greater legal requirements. Must have full name, no abbreviations. Must show all constituents. Applies to any recovered chemical, whether used, excess, spent, etc. Chemical disposal containers. Hazardous materials must be disposed of through environmental health and safety. Containers must be closed, appropriate for contents, and in good condition. Must be tagged for disposal. Contact EHS with any questions. In general, better to assume something is a hazardous material. If it is not, EHS will tell you, than to risk a federal crime by putting a hazardous material into the trash or the sewer. Unknown chemicals. Major problem. Presumed to be hazardous material until proven otherwise. Label everything. Don't allow materials to become unknowns. If you discover unknown materials in your lab, attempt to identify them using your own knowledge and records. Ask your advisor, the safety committee, or EHS for assistance. Chemical spills. What should you do? For any spill, alert others and close off the area. Chemical spills. Bare bones procedures. Acids. Confine, neutralize, bicarbonate, clean up, dispose, call EHS. Flammable solvent. Eliminate ignition sources, confine, absorb, clean up, dispose, call EHS. Mercury. Consolidate, collect, dispose of, wash yourself. Solids. Scoop, place in container for disposal by EHS. Electrical hazards. High voltage is equal to special hazards. Do not work on electrical equipment unless you are sure it is de-energized. Before touching an unconscious person, check for a source of electricity. Avoid spark sources near solvents. Should not obstruct work or aisles. Extension cords only for short-term use. Power strips can be used long-term. Do not daisy chain cords or power strips. Discard and replace damaged cords. Flood prevention. Easy steps. Minimize unattended water use. Clamp hoses onto fittings. Clamps best. Wire okay. Cryogens. Liquid N2, BP -196 degrees Celsius. Use only with good ventilation. Be careful about condensing O2. Dry ice acetone slushes are not as cold, -80 degrees Celsius, but have high heat capacity and stick. Frostbite can result in seconds. Rinse skin under cool water. PPE, heavy leather gloves and lab coat for short-term use of cryogens. If the gloves or coat get soaked in a cryogen, quickly take them off and move away from the hazard. Which accidents are most common? What do you predict? Personal risk injury? Property damage? Thank you for attending.